Hello guys, welcome to Green Academy. Let's discuss a projection of line problem based on plane rotation method. The problem is a line PQ has its NP 10 mm above HP and 20 mm in front of the VP. The end Q is 35 mm in front of the VP and the front view of the line measures 75 mm. The distance between the end projectors is 50 mm. Draw the projection of the line and find its true length and true inclination with HP and VP. So here let's read once more. So what are the data given? So in this question it's not given that which method we have to follow. We can follow line rotation method as well as plane rotation method. So if in the question paper or in the question it is not clear which method we have to follow, so you can follow either line rotation or plane rotation. If in the question if you can spot something like the distance between the end projectors, if the distance between the end projectors is given, you must follow plane rotation because it is the easy method. Plane rotation is always easy method. Okay, suppose in this question it's also given that follow some special method, like in the question it is given that follow line rotation, then you have to follow the line rotation. If nothing is given and just find out is there is any distance between end projectors, then you have to take plane rotation method because this is the easy method. And what is given is a line PQ. The name of the line is PQ and it's NP 10 mm above HP. So it is 10 mm above HP and 20 mm in front of VP. So the P is in the first quadrant and the end Q is 35 mm in front of VP. It's saying the Q is 35 mm in front of VP. Okay, we can assume the line is in the first quadrant. And how much distance from HP? No, that's not given. The end Q is 35 in front of VP. Only one distance is given. And the front view of the line measures 75 mm. So the front view of the line measures 75 mm. What is this front view? This is the reduced length, not the true length. Okay, the distance between end projectors is 50 mm. Distance between end projector is given, that is 50 mm. Draw the projection of the line and find its true length and true inclination. So we have to find out the length of the line, true length and true inclination with the VP and HP. That means theta and phi. So the first step, the first step is you need to draw the basic figure for plane rotation. So what is the basic figure for plane rotation? This is our XY line, and suppose this line A, this is front view of the line A dash, and maybe this is top view, and this is the, suppose the distance between end projectors, this is the distance between end projectors, one projector and another projector. The distance between the end projectors is given, this is 50, and here this is your B dash, and suppose this is your B. We are following plane rotation method. You need to draw this A dash and B dash, A dash, B dash, A, B. This is the reduced length of the front view and this is the reduced length of the top view. By plane rotation method, you need to measure this length. Before that, you need to draw a perpendicular from this end points, and here also you need to draw just perpendicular. Okay, you need to measure this length and you need to mark the point A. Okay, you need to transfer this length from here to here. So this length is equal to this length. What about here? This length is equal to this length. So this is our B. This is our true length. Same goes for here. This is measure this distance and you mark the point A here. Here also measure the length and copy the length here to here. This is our B. This will be true length. This true length must be equal to this true length. And what about theta and phi? You need to extend both the top view. This will be theta, and you need to extend both the front view. This is phi. The point at which both the reduced length and true length meet is HT, and the projection into the XY line is known as H dash. Here also this is VT, this is V. Okay, in this in this point, what is given in this problem? It is given that distance between end projectors is given, this length and this distance is given, and also in front of VP this is not given, this is 35, this is also given, this is 10, this is 20, this is not given. How much distance from HP is not given, but it is given. Distance from the VP is given. Can we draw the projection? Let's try. XY. Okay, this is 10 mm above HP. Suppose this is 10 mm and A dash, and this is 20 mm. This is 20 mm in front of VP. This is A, and distance between end projectors is 50. Measure 50 and draw a projection and the projector. So the point B must be here. It is P dash P. The point Q will be in this line. So at what distance? It is 35 mm in front of VP. So measure 35 from here to here. This will be our Q. This is our reduced top view. Okay, and what about the front view? Front view of the line measures 75 mm. So we know the front view. Take a front view in compass, just mark front view 75. This is 75. This will be our Q dash. Okay, and what is the next step? You need to draw projections perpendicular. Here also you need to draw perpendicular from P and Q. Measure this length and mark here. This will be this length is equal to this length. This will be P, and here also this length will be equal to this length. Copy this length from here to here and mark the point Q. This will be our true length. Repeat the same step here. You will get like this. This is the true length. This true length must be equal to this true length. And how to find out the theta and phi? Extend this line. This is theta, and extend this line. Whenever it's meet, that is VT, you will get V. This is phi. XY line. So P is 10 mm above HP and 20 mm in front of VP. 10 mm above HP and 20 mm in front of VP. This is P dash P, and distance between the end projection is 50 mm. 50. Just draw a line. This is the end projection. And what is the Q? Q is 35 in front of VP. 35 in front of VP. In front of means in first quadrant it's below XY line. 35. This is our Q. This will be our front view, top view, reduced length top view. And what about this PQ dash? This Q dash is given. The length from XY line, no, it's not given, but length of the front view is here. The front view of the line measures 75 mm. So length of the front view is given. So take 75 mm in a compass. This is our 75 mm. Can cut an arc here, 75 mm. Okay, so we need to extend this line. So this is our front view. This is our front view. This is our Q dash. Next step is you need to draw perpendicular, either this direction or this direction. In this direction, so I am taking this direction. We can draw either this direction or this direction. I am taking this direction, and first this is our, I am drawing perpendicular in this direction. Okay, here also, so this is our perpendicular in this direction. This is 90 degree. This is 90 degree. Here also I am drawing perpendicular. This is 90 and this is 90. Transfer this length from here to here. So I am taking the length by compass. Okay, this is our distance. and transfer this length from here to here. Measure this distance and mark here. Also transfer this length from here to here. You need to measure this length and mark the point here. Also take this distance and transfer here. Okay, this is our point. I mark the point. So this is our PQ. This is our PQ. This is our true length from the front view, and here also this is our PQ. This is our true length. This must be equal. This true length must be equal to this true length. Okay, what about the length? This is, suppose this, it says is 76 something, and here also, yes, it is 76 something, right? 76. True length is equal to 76. Okay, and if you measure this angle, this will be 5, and if you measure this angle, this will be theta. And here how to measure this angle? So if you don't need to extend the line because it may be out of our paper. You don't need to extend this line. The simple method is just draw a parallel line. Just draw a parallel line here. Suppose this is the parallel line. Just draw a parallel line. Just draw a line parallel to this true length and measure this angle. This will be 5. Here also draw a parallel line and measure this angle. This is theta. You don't need to extend the line. If you want to find out the traces, you need to extend the line. Okay. So next is dimension. You know how to make the dimension. Dimension is very simple. Just mark. This is our. It's already given. How much is this? Is 10 and this is 20. And what about this? This is given. This is 35. This is 35, and true length. This is also given. So this is R75. R75. Okay. This is the dimension. So you need to measure the true length. This is 76, and theta 5, and put it in a box. Here you need to write all dimensions. Dimensions are in mm. Okay, this is the solution. Thank you.